Welcome to my first update on Frantic Factories. Frantic Factories is a factory management game I'm developing that will challenge players to fully optimize various small factories, building conveyors and machinery to take inputs and produce the required outputs. While hardly revolutionary, this idea was born from a desire to combine and simplify aspects of my favorite games. I enjoy the management and problem-solving aspects of games like Mindustry and Oxygen Not Included, but usually prefer games like Mini Motorways that have less of a time sink to get to the fun parts. I don't usually have hours to dedicate to a single playthrough, so I'd like to reduce time requirements and allow players to build and complete a factory in just 15 to 20 minutes. I also envision each level feeling a bit like a puzzle, which, combined with leaderboards, will challenge players to compete against each other to build the most optimized factory possible. Many details are still up in the air, so stick around for future devlogs to see how the game progresses and changes over time. So far, I've been focused on building the core engine that will power the game and handle simulating a factory. Each level in the game will be represented using a grid of tiles that will hold things like conveyors and items. Every second or so, I'll update the simulation one step, moving items one tile at a time according to the conveyor they are on. These discrete steps, or ticks, will make the simulation fast, but more importantly repeatable. Players should be able to build an understanding of how each tile works and get consistent results from consistent inputs. The basic simulation algorithm is pretty simple. Every time we want to update the simulation, we'll just iterate over every tile in the level and store a list of changes made by that tile. For example, a conveyor would store a change moving the item one cell in the direction it is facing. After processing all tiles, we'll apply the list of changes to calculate the new state of the simulation. We could let tiles update the game state directly, but this can lead to some really weird situations where an item gets moved twice in one update. Now that we have a goal, let's see how quickly we can screw up the initial code. My first goal is to create the structures for our basic game elements, the tile and tile map. At its core, a tile is anything that can be updated over the course of the game, like an item or a conveyor. The only real requirement is that a tile implements a tick function to let us know how to update it when we run the simulation. We'll give the tile information about the current game state, and it will return a list of changes we should make to update the simulation. I also require tiles to implement a format function, and that's mostly just useful for debugging. I'll show you guys what that looks like soon, and keep in mind that I have done zero graphical work so far on this game. All the animations were made just for this video. The tile map, on the other hand, is responsible for storing the positions of all tiles in the game. 3 hash maps are used to store tile information, and these let us look up tiles by position, type, and ID. And yes, I am sure there is a better way, but sometimes you just gotta go with the first solution you think of and move on. I've also gone ahead and added helper functions for adding and accessing tiles. So if I do want to change out these underlying data structures later, it shouldn't affect the rest of the code all that much. Now that the basic building blocks are in place, let's get to the fun part, making a conveyor actually do something. Okay, let's take a look at the tick function for a conveyor. This function is what is actually responsible for moving the items on a conveyor. The logic here is simple. First, we'll check if there's an item on the conveyor to move. Next, we'll calculate the position we should move the item to based on the direction the conveyor is facing, and then return the position as a requested change to the item's position. Okay, after a lot more floundering that you probably don't particularly care about, let's see what we've managed to build. Oh, and just for fun, and not at all because I can't be bothered to create another animation, let's take a look at that debug view I mentioned earlier. For now, the only way to actually see what is going on inside the simulation is inside a terminal window. I'm using characters to represent the conveyors and items, and updating the display every tick. I also include some information about which tick we're currently on, and how long it took the computer to process the simulation for that tick. Though, let's be honest, I'm just ignoring that number for now, though I'm sure we'll need to optimize down the road. While working on this visualization, I also added 2 new tile types, besides the conveyor and items that we've already seen. I added a spawner to create items at set intervals, and an incinerator to destroy items. I also set up some code to randomly generate conveyors for easy testing. It's pretty satisfying to finally have something working. Okay, what we have so far clearly works, but is pretty dumb. For example, the program will happily move 2 items onto the same cell, it drops items off of conveyors, and has absolutely no idea how to handle intersections. Let's fix a couple of these issues real quick. We can easily add checks to prevent moving more than 1 item onto a cell, and to stop conveyors from dropping items onto the ground. I also used this time to finally add some unit tests to the game, which is something I've been wanting to do for a while. To make testing easier, I added an EQ function to the trait definition that lets us compare tiles for equality. This led me down a bit of a rabbit hole trying to figure out how to use Rust's partial EQ trait with a box, and long story short, it doesn't seem to work, and I frankly don't know enough about Rust internals to know why. It's very frustrating. Let's take a quick look at how the EQ function works for a conveyor anyway. Since we are passing around boxed tile traits, we actually first cast the tile as any, and then use downcast ref to cast it to a conveyor struct. This is honestly pretty cool, and does not require using unsafe code. I'm using the same technique in the tile map to query for specific tile types at a given position, just by passing the correct generic type. Some of you might remember that I actually still haven't properly implemented intersections. Getting intersections working in a predictable way is the last hurdle I'd like to clear before moving on to graphics. The main issue is determining which conveyor has the right of way. Take this 4-way intersection, for example. We can only move 1 tile onto the incinerator in the center, but which conveyor should get to move its item? Should we just alternate between all conveyors, kind of like a traffic light? For inspiration, let's take a look at some other games with conveyors to see how they solve this problem. Mindustry, a factory management tower defense game, handles this problem quite nicely by simply alternating between conveyors. This is similar to how I envision my game working. Another game I thought would be useful to look at is Baba Is You. It's a tightly programmed grid-based puzzle game that kind of also just happens to have conveyors. Turns out, though, it just cheats. I mean, look at this nonsense. The items just overlap. This is specifically what I want to avoid. Anyway, I hoped Baba would be more useful since it also updates tiles in a nice grid, but no such luck. Other games, like Satisfactory and Shapes.io, don't allow conveyors to be connected to each other directly at all. Instead, they force players to use a dedicated merge building that essentially removes intersections from the game. I kind of want to limit the number of buildings in my game, so I think the solution that makes the most sense is just to alternate between conveyor directions at an intersection. To accomplish this, let's go back to our tile definition and modify it slightly, adding a priority function. Now, each tick of the simulation will order tiles according to their priority, and then update them in order. For example, here's the new priority function that handles conveyor intersections. It's a mess, but basically every tick we change which conveyor in the intersection is updated first. First conveyors facing down, then left, then up, then right. It might be better to construct a graph and more intelligently process interdependent conveyors, and there's still plenty that could be done to improve this simulation, but it'll work for now. Here's how intersections behave after these changes. Look how orderly everything is. My next order of business is to start adding actual graphics to the game, and maybe even a user interface, but let's not get too crazy. For now, this is all I got for you, so stay awesome, and thanks for watching.